Tools is a really useful little trick that Ronnie came up with to help you tackle the exam style questions that will come from chapters 2 and 6, because they don't really come like a differentiation question or an integration question. Normally they're all mixed up together, so it's really helpful to think about them in this way. So Tools works by giving you an easy way to remember 5 pieces of information. The first one, represented by the T, is triangle area, and we will go through the formula in just a moment. The second one is O, which doesn't seem to make any sense, but I will tell you it's sector area, and we will talk about why it's represented by an O in just a moment. The next one is arc length. L is your last resort, and that is the cosine rule. And the S represents, obviously, sine rule. Okay, so some of these you should be familiar with, others will be completely new to you, but that is obviously the point. So, triangle area, we know, is a half AB sine C. You will have seen that in your GCSE. Cosine rule, obviously, A squared is B squared plus C squared minus 2BC cos of the angle A. Horrible formula, but very useful on occasion. And then the sine rule, sine A over A is sine B over B, which is sine C over C. We'll talk about how to use all of these. Okay, sector area is a half of r squared theta, and arc length, L, is r theta. Now, what on earth do they mean? Well, we've got an OO there in Tools, and if you know anything about Doctor Who, you will have met the OODs, and I had fun drawing a little OOD there for you. And the OOD says, if you've got an OO, you're talking about circles, which means you need to be in radians. Now, if you have missed the video before this on what a radian is, please go back and have a look at that, because this will not make much sense to you if you haven't got some idea of what a radian is. Okay, so our first one then was the triangle area, and we know that that formula is represented by half AB sine C. So when we have two sides with an angle in between, and they can be represented by, you know when you hold up a peace sign, you hold up a V on your fingers. There's my very bad little sketch of it. If you can fit the length, known lengths on your fingers with an angle in between, you can use the triangle area. So if I put the peace sign here, I've got the length of 12, the length of 4, and an angle in between, which means I can use the triangle area. And so the area of this little triangle here would be a half times 4 times 12 times sine of 20, which I believe is 8.20848, something like that, which is 8.21 to 2 decimal places. Okay, so if you can find the peace sign, if you can find the lengths, two lengths with an angle in between, you can use the triangle area. Now, obviously, that's going to be when it asks you for an area, but it might well be tucked up in a whole load of other stuff. Okay, sector area. What is a sector? Well, a sector is a slice of a circle. So, for instance, if I draw you a little circle, then the bit I've just shaded is a sector, and I want to know the area of it. Now, in GCSE, you will have done this, and you will have told me that if you know the angle, so say we know that that is 60, then you'd find the area of the circle, and then find what 60 of the total 360 degrees of that area is. Now, that's quite a long-winded method, and luckily in A-level, you've got an easier way of doing it if you are in radians. So the OOD tells you you're working with circles because you're dealing with OOs, and also that you must be in radians. So here is my angle pi by 6. That's an angle in radians. If that had been in degrees, you would have to convert it. So degrees must always go to radians, even if the question is throwing you and trying to give you something in degrees. Okay, so the sector area is a half r squared theta, and theta is always the angle that you've been given. So if I want to find this little area in here of my little slice, then I'm going to do a half of 10 squared times by pi by 6. Now, depending on how they want you to give your answer, they might say to a certain number of decimal places, in which case you just put all of that in your calculator and off you go. Or they might say giving it an exact form, which would mean leaving it in pi. And if we leave it in pi, we've got half of 100, which is 50 times by pi over 6, so 50 pi over 6, which we can cancel down to 25 over 3, lots of pi. And that is the area of that little sector there, so that slice of our circle. Arc length then. So we've talked about the area of a sector. What about the area, the length of the part of our chunk of our circle there? Well, we know what a radian is. A radian is the angle that means that when we've gone r along the outside of our circle, that's the angle that's formed there. So we've got our radius, and if we took that length and walked around the circle that much, from where we started to where we stopped, the angle that we've covered there is a radian. Okay, so if I tell you I've got 2 pi lots of radian, 2 thirds of pi, I can't read fractions this morning, 2/3 of pi radians, all I need to do to find out that length is to multiply it by the radius, because I've got 2 pi over 3 lots of the radius. There, that's what I'm trying to traverse, is that distance there. So that is 18 pi over 3, which is 6 pi. Now, we're talking about pi's in the angles, we're talking about pi's in the length. Don't forget pi is a number. Pi is just a number, so we've got 6 lots of 3 point something, something, something. So we have, nearly 19, if it were in centimetres, if this was 9 centimetres, we've got 6 pi centimetres as that part of our arc. So just to recap then, the length, the arc length, is the angle multiplied by the radius, r theta or theta r. This is our last result, so I'm actually going to come back to it. Oh my goodness, come back to it last, and I'm going to look at the sine rule. So we know that sine rule is the sine of the angle A over A is equal to sine B over B, which is equal to sine C over C. And you know you really only need 2 of those to be able to work out one piece of information. But the key with the sine rule is that we've got A and little a. Now big A obviously represents angles, little a represents sides. So we need an opposite pair that we know. Now in this question here, we know both 12 and its opposite angle. And then we're interested in finding out what x is, so we'd need to know something about its opposite as well there. But we've got one pair that we know and one pair that we're trying to find out information about. So it doesn't matter which way you label it, in fact you don't even need to label it, but let's label it for this case. Let's say that this is A and that's A, and we're just going to choose this as B, angle B obviously, and then side B. So sine A is 100 over A, which is 12, is equal to sine B, which we don't know, sine of x, over 4. Now, luckily, my unknown is on the top. It is normally much easier to keep your unknown on the top of the fraction, but you could just as well have had the fractions the other way around, so 4 over sine x. The only thing then is you'd have to do 2 sort of manipulations of that to get back to an x equals. So you could then work this out on your calculator, obviously, and I will do that. So sine 100 over 12. Now, are we in radians or degrees here? 100 suggests we're in degrees, even rather. It would be a much smaller number otherwise. So first things first is always to check that your calculator is in the right type of angle, and mine is. That's fantastic. Okay, so we've got sine 100, and that answer is being divided by 12. So that is 0.08206 something. And that's equal to sine x over 4. So why don't we multiply that by 4, and that will leave us with just sine x. So I'm just going to multiply straight by 4. That is 0.32826 onward, and that is sine x. To get out x, obviously I need to do the inverse of sine. So sine to the minus 1 of 0.32826, etc. Obviously, the more you can just leave on your calculator and apply this just as a function after a function, hitting the answer button is really helpful. It keeps you very accurate. So that is 19.1637 and onward being x. So x, our angle x is 19.2 degrees to 1 decimal place. Back to the cosine rule then. So if you've been through all of your other options and you've gone, no, I can't use the triangle rule, the area of a triangle. No, I don't need the area of a sector. No, I don't need an arc length. And I haven't got my pairs to match. For the sine rule, your last resort is the cosine rule. And the only reason it's the last resort is because it's messy. It's horrible and messy, and you always get something wrong. Okay, so there's our formula. A squared is b squared plus c squared minus 2bc cos a. So what we need really here, since we're finding an angle, is all three of the other sides, which luckily in our case we do. So notice we've got a and a being the only one repeated twice, little a being a side in the capital A. So actually the one that we want to fix as a has to be an opposite pair. So a squared will be the opposite to the angle we're trying to find, which is 8. So 8 squared, and then b and c can go anywhere you like. 4 squared plus 10 squared minus 2 lots of 4 times 10 times by cos of x, which we do not know yet. Okay, so 8 squared is 64, that's 16 and 100. That is 80 lots of cos x. So all I've done there is obviously expanded out the squares there and just work them out, and then this bit is that number there. And I've left my minus sign as it is, and I've left cos as it is. So what I've done is just put things into numbers, because that can now help me quite a lot. So very quickly then, 64, take away 16, take away 100 is minus 52. And that's equal to minus 80 cos x. Don't let that minus disappear just because you've moved other stuff over. It is attached to the 80 cos x. It is minus 80 cos x. It's not 16 plus 100 and then a floaty minus that you can have or not have. Okay, so minus 52 divided by minus 80 is 0.65, and that's equal to cos x. So again, to get x, we need to do the inverse cos to the minus 1. Shift answer, and that is 49.5 to 1 decimal place. And there you have it. So when you're facing an exam question and it looks like it's going to be heading in this direction, can I suggest you write down tools? That's your first step. Then you know that you can remember what each part is, and hopefully by the time you get to exam you will actually remember what each part of tools is. You can then select the formula that you want and write it down. So this is when you're in the exam and you're freaking out a little bit, select your formula and write it down. Substitute in what you know. So watch the pieces of information that helps you decide which formula to use, put them in, the things you know. And then obviously all you're doing is solving to get the missing information, which should hopefully be your answer.